Okay, so here we're supposed to just rewrite the expression so we can add the numerator. The denominator is already set, so we're not going to do anything with that just yet. But if I'm going to add the numerator together, I need a common denominator. Now I can't just say, oh, well, let's just add 7 to this so that I have an x plus 2 and another x plus 2. It doesn't work. You can't add something to the top and the bottom of a fraction and have it retain its value. It's only multiplying by 1 will make it equal. If I add 1 to something, the value's changed now. So the only thing I can do is say, well, this is part of my denominator, that's the other part. So this guy is missing an x plus 2. So I'm going to do the x plus 2 on the bottom, but I also need to do it to the top. The nice thing about that is it's a 1 times that, so it just remains that. And so there's part of my denominator, but now I've got this. Okay? So now this is an x minus 5. Now the denominator is complete, but I got to make sure I do that to the top too also. Okay, so all that, we're rewriting the expression so you can add the numerator. I'm not adding it yet, but I'm going to say blah, blah, blah. This thing is down there. I'm not doing anything with that, so I'm not going to rewrite it. But up top, I've got an x minus 5 plus an x plus 2. Now, they're in parentheses. You can keep them in parentheses, but please, whatever you do, don't think that because they're in parentheses, I need to multiply now. Because that right there says I don't want to multiply. I'm just going to add. Combine like terms. Now the denominator, as we've already seen, is an x minus 5 and an x plus 2. Also, please don't do this. Oh, I'll just cancel all these. It's equal to 1. This is a product. That is a sum. They are different. We cannot treat them like they're the same. Okay? What I can do, however, is look at the numerator and combine like terms. If I combine my like terms, what does the numerator become? 2x, x plus x, minus 3, which is the negative 5 and the positive 2. So, a quick recap. This is my numerator of my numerator. This is the denominator of my numerator. And this entire thing is the denominator down here. Okay? So, what we're going to do, we're rewriting the expression from number 4 as a division problem. That's saying now that I've got a 2x minus 3 over x minus 5 times x plus 2 divided by the 2x squared minus x minus 3 over the x squared minus 3x minus 10. Now that whole madness there, the way we write it like this, it's easier to see, oh yeah, the divided by means I'm going to change this to a times and flip-flop this, and I'll factor as I go. So this thing here factors to be x minus 5, x plus 2, and this thing here will factor to be something down here. And I'm just going to kind of go, I guess, a quick diamond box or pairing type thing. This and that gives me a negative 6x squared. That's a negative 1x. Two numbers that multiply together to get that and add together to get that are a negative 3x and a positive 2x. Those things now become a substitution for that guy in the middle. Okay, so I've got a 2x squared minus 3x plus 2x, and then back to the equation minus 3. Group those guys together and take out an x. 2x minus 3. I can't take anything out of here, so I'll say plus 1 times 2x minus 3. And my two factors now are 2x minus 3 and x plus 1. Now it's a big cancel fest. The 2x minus 3 is gone. The x plus 2 is gone. The x minus 5 is gone. All I have left is this guy on the bottom. But if I only write x plus 1, I'm wrong. Because the 1 is in the numerator.